control at Cape Kennedy for the duration of the 8-day mission. The complicated technology of Apollo Saturn evolved from an ingeniously simple concept: lunar orbit rendezvous. This requires a rocket made in many pieces that discards the useless weight of each piece when its function is completed. The flight began with a vertical lift through the heavy lower atmosphere and a tilt to the east. At 6,000 miles per hour, the empty first stage is discarded to save weight. So is an adapter ring and the unused escape tower. With the second stage firing, it reaches 15,000 miles per hour when it too is jettisoned. The third stage places Apollo in Earth orbit at 17,400 miles per hour. When the spacecraft has been thoroughly checked out by the crew, the third stage fires again, its speed now tearing it free from the grip of Earth's gravity. While coasting outward, the command service module separates and docks for access to the lunar module, and the empty third stage is left behind. Apollo loses speed throughout 9/10 of its journey until the moon's gravity overcomes the pull of Earth. Apollo fires in reverse direction, slowing down enough to be captured in orbit about the moon. Armstrong and Aldrin enter the lunar module Eagle, which separates, leaving Collins and the command service module in lunar orbit. Eagle slows still more and brakes to a touchdown on the lunar surface. After the moonwalk, the upper stage of the Eagle lifts off, leaving behind the now useless landing stage, and swings into orbit to dock with Columbia once again. When the crew and moon samples are transferred to the command service module, the lunar module is discarded. The command service module fires itself out of lunar orbit and falls back to Earth. As it approaches the re-entry speed of nearly 25,000 miles per hour, the service module drops away. The command module plunges into the atmosphere, protected by its heat shield. Slowed still more by the heavy lower atmosphere, it parachutes into the sea. The command module, Columbia, is all that remains of the original 3,000 tons of rocket, fuel, and cargo.
Apollo 11, this is Houston, over.
While in Earth orbit, the Apollo crew had less than 2 hours to check out all their spacecraft systems. The last chance to discover and correct any malfunction before the third stage engine is restarted to break them free of Earth. The translunar injection.
We're 10 minutes away from ignition on translunar injection.
Apollo 11, this is Houston. You are go for TLI, over.
Apollo 11, thank you.
Roger that. Apollo 11, this is Houston. Slightly less than 1 minute to ignition, and everything is go.
Roger. Ignition.
We confirm ignition, and the thrust is go.
Apollo 11, Roger. Guidance looking good. Velocity 26,000 feet per second. Telemetry and radar tracking both solid. Velocity 27,800 feet per second.
Through the window of the command module, the Earth gently slipped away.
Apollo 11, this is Houston. Thrust is good. Everything's still looking good.
Roger. 29,000 feet per second, building up toward 30,000 feet per second.
Apollo 11, this is Houston. Around 3.5 minutes. You're still looking good. Your predicted cutoff is right on the nominal.
Deep space tracking antennas, a third of a world apart, listened to Apollo and spoke to Apollo. As the Earth turned, at least one of them would have contact with Apollo at all times, except when it passed behind the moon.
34,000 feet per second now, altitude 152. $35,000 feet per second. Cut off. We're showing velocity 35,570 feet per second, altitude 177 nautical miles. At 3 hours, 11 minutes into the mission, distance from Earth, 3,140 nautical miles. The S-4B is reported in a stable attitude for this separation.
Apollo 11, this is Houston. Your go for separation.
Okay, Apollo B coming armed. My intent is to use bottle primary one as per the checklist, therefore I just turned day on.
Roger, we concur with the logic.
We're awaiting confirmation of separation.
Roger.
We confirm the separation here on the ground.
Apollo 11, this is Houston. Radio check, over.
The Goldstone station reports a very weak signal. We believe that Mike Collins is now maneuvering the spacecraft in the transposition and docking maneuver, and the antenna patterns aren't too good at the moment. So we have a weak signal strength.
The command service module separated and turned around to dock with Eagle, the lunar module.
Apollo 11, this is Houston. How do you read? Apollo 11, this is Houston. Radio check, over. Roger, we're copying you about 5 by 2. Very weak. Can you give us a status report, please? Loud and clear now, Mike, and we understand that you are docked.
That's right. Hello, Apollo 11, Houston. We recommend you accept the 949, continue through your sequence of sightings, and then we'll analyze the data afterwards, over. Okay.
On board was a fourth brain, a small computer called Disky, which solved problems and helped with a long sequence of systems checks and data exchange with Earth.
Houston, Apollo 11, star 40 has just disappeared now in the sextant. Could the trunnion angle 47 something be a little high? Stand by. Hello, Apollo 11, Houston. We'd like you to press on to star 44, over. Yeah, roger. How many more?
They found their way across the sea of space, navigating by the same stars that guided Columbus to shores unknown.
11, Houston, we copy. 2 good marks, over. Okay. Okay, drug removal is coming next.
3 days falling to the moon, free of the gravity of Earth. No up or down, no day or night. A sense of stillness while traveling at the speed of a meteor.
About how long it'll be before you start closing the limb back up, over.
An invisible speck in the night, somewhere between here and there, constantly monitored from Earth. Within this tiny spacecraft, a temporary Earth environment, warmth, air, food, water, everything necessary to sustain life. Beyond these fragile walls, nothingness, absolute cold, an end to life. The most important function of the spacecraft, life, was also monitored constantly through telemetry, the heartbeat and breathing of each astronaut. Although each breath was 30,000 feet farther from Earth than the breath before it. Should one heart flutter, it would at once be a matter of concern to millions worlds away. Unlike any other place man had traveled before, space could provide him with nothing. It is a vacuum, devoid of every element needed for life. To send man into this nothingness, to protect him, it was first necessary to define him. What is the human machine? How does it function? What is the nature of its nervous system? its respiration, its circulation, digestion, sight, hearing, balance, its endurance. What gases to breathe should he take with him from Earth? What atmospheric pressure suits him best? Is it possible to give him a more efficient atmosphere for space travel than nature provides on Earth? The moon is 250 degrees hot in sunlight and 240 degrees below zero in the middle of its night. How long can a man bake or freeze? What protection will he need from this inhuman environment? What strains will the heart take when the pressure of gravity is removed from the limbs? What protection will the body need from sudden deceleration or acceleration? Man's sense of direction, speed, and balance are easily fooled. Can his mind be trained to ignore false signals from his senses? We were defining the physical man in absolute terms. Once we knew man's limitations, we could build him an artificial environment for space travel. Columbia, the command module, was a supreme achievement of the technology of its age. It was a mini planet, complete with its own environmental control system, telecommunications, electrical power, guidance, navigation, stabilization, propulsion, reaction control. It provided hot